Great, everyone can see that. Please, as I go along, just interrupt with questions because I can't multitask and monitor the chat at the same time. So just unmute yourself and interrupt, please, at any point to ask a question. My name's Ellen Bruno. I'm a Cooperative Extension Specialist in the Department of Ag and Resource Economics at UC Berkeley. Just almost wrapping up my second year here in this position. And I want to present a paper that I'm working on with Katrina Gesso, who's at UC Davis in the Ag and Resource Economics Department, and Michael Hanneman, who's at Arizona State University, but is Professor Emeritus from Berkeley ARE. And so I want to tell you about this paper that's looking at the impacts of agricultural water pricing and what that means for water use and land use change. I'm going to start with a very broad motivation to this research, which is the tragedy of the commons, which is a concept that was popularized by Garrett Hardin in 1968. And it refers to a certain class of resources, particularly ones that are non-excludable but rivalrous. So meaning anyone can access the resource, and one person taking advantage of the resource means that there's less available for other people, and are commonly called common pool resources. And so we could think of fisheries, for example, where in a setting where anyone can go out and catch fish, but if one person catches a fish, that means there's no longer that fish there for other people to catch as well. And in general, we think that the incentives for an individual using this type of resource are not well aligned with sort of what's in the general public interest and what would sort of maximize the well-being to everyone in society that benefits from that resource. Like the private incentives are not well aligned. And so generally, we think that in the absence of either regulation, privatization of the resource, or some sort of Elinor Ostrom style local community governance, that in most cases, when you have a common pool resource, it can lead to overuse of the resource and in some cases collapse of the resource that is not great. And so groundwater is a classic example of a common pool resource. In many places, the property rights for the groundwater itself are not well defined. We don't think of this as a private resource. And at the same time, it's not regulated in many cases, and oftentimes not even metered. And so this can lead to issues of over extraction of the groundwater resource. So we could think like if I'm farmer A and I'm pumping a lot of groundwater, I might notice that my own pumping might increase my costs of pumping because I'm drawing down the water table, and that raises the energy cost of extraction. But it might also increase the cost to my neighbor. And when I'm making my individual pumping decision, I'm not necessarily taking into account that I might be creating greater costs for my neighbor. And this is what the definition of a negative externality is. And we think this has contributed to the reason why many of our groundwater aquifers worldwide are under stress. There are externalities in several dimensions when it comes to groundwater. It's not just what I explained in terms of making the energy costs greater for my neighbor, for example, but it might mean that it makes it harder for any individual to plan for the availability of the resource in the future. If anyone can come in and extract that resource, you can't assume that if you don't extract it today, that it could be available in the future. And then there are also water quality externalities too. It's not just about the quantity of the groundwater, but one person's pumping could affect the quality of their neighbor's groundwater. So with all of that, I mean, all of these groundwater externality issues could potentially be exacerbated by climate change. So we know that climate change is going to impact our water supplies in several dimensions. The first, through increased temperatures, we expect to see changing both the form and the timing of precipitation. So in California, we are thinking about there being less snow and more rain, and having the snowpack melt earlier in the season, and this complicating how runoff gets captured in reservoirs and used later in the year. And we also expect climate change to create conditions of more variable precipitation with more frequent and severe extreme events like droughts and floods. And we know that groundwater is a really important buffer to variation in surface water supplies and rainfall. And so when we have more frequent and severe droughts, there's going to be an increased reliance on groundwater supplies. And we've seen this historically in past droughts, that farmers have relied on their groundwater supplies to make it through those changing conditions. And so it's all the more reason to be thinking about why we should manage groundwater and think about the use and allocation of this resource. So one way that economists have sort of long thought about correcting some of these negative externalities of common pool resources is by taxing the resource. The idea being that if we could change the price to use that resource, that people might change their behavior such that it's more aligned with what would be in the public interest, and sort of correct these instances where the individual incentive is not well aligned with what's good for overall society. And so we're specifically thinking about this concept in the context of agricultural groundwater, which, as many of us know, agricultural groundwater is typically not priced, where your average farmer in California will pay the cost to pump the groundwater from below. I mean, that has costs. It's not totally free, but the actual groundwater itself is not priced, right? You're paying the energy costs to extract it. And so we, a policymaker or an economist might think about pricing as a policy instrument to correct these consumption externalities. Groundwater pricing might also be important in the context of technological innovation. We think that input prices spur technological change, and therefore the absence of a price would dampen the incentive for technological change. We've seen, empirical evidence of this happening in other sectors, like when we see an increase in energy prices, there's an increase in energy efficiency, innovation related to energy efficiency, and same with carbon. People have studied carbon markets in the EU and how that's driven low carbon innovation. And so pricing of water could also be important when it comes to thinking about the adaptation to climate change and potentially increasing water scarcity in the future. So we're thinking about water pricing as potentially serving as both a corrective policy instrument for the overconsumption associated with groundwater being a common pool resource, and also as an adaptation strategy to climate change and changing water supplies. So what our paper is going to do is zoom in on a specific irrigation district that happens to already charge a water pumping fee for agricultural users, to try to examine empirically what the presence of a water price has done for water use and land use change of those agricultural users in that particular region. We're gonna try to estimate the effect of the volumetric groundwater pricing on a suite of different behavioral changes: agricultural water use, land fallowing, crop switching, and the conversion of land out of agriculture entirely. The goal is going to be to try to identify the causal impact of these water prices on these different metrics, which is a challenge in a non-experimental setting. And that's something that I'm going to talk about as we go forward. But ultimately, we want to understand how water pricing actually causes these different factors to potentially change, to understand how farmers respond to the introduction of groundwater pricing. So trying to do this is challenging for a number of reasons. You know, I mentioned before that in many cases, groundwater use itself is unmetered. And so it can be challenging to get data on sort of well level agricultural groundwater extraction. And then furthermore, it's fairly uncommon to see water pricing for agricultural groundwater that we are trying to investigate. Data issues aside, once you know how much, what prices people are facing and the water use that they're doing, that the groundwater they're extracting, and you can observe the land use happening, it can also be difficult to sort of understand what the appropriate observational unit is in this study. Like, we're trying to study grower or farmer behavior, and so ideally you would want to know which parcels of land all correspond with each other in terms of, we see this well and how much water use is occurring at this well. What parcels of land is that well watering, right? And so that can be challenging as well. And then finally, we're talking about using observational data to try to come up with a causal estimate. And so we're working within a non-experimental setting, but trying to identify causality if possible. And so I'm going to talk about all of these components and sort of how in this particular experiment, this particular empirical setting that we're working in, we're able to overcome some of these margins to try to get closer to our understanding of how water prices affect water use and land use. So we're zooming in on the Pajaro Valley, which is on the central coast of California, a region that Sam is very familiar with. It's a very productive agricultural region of about 30,000 irrigated acres. They're known for their strawberry production. Driscoll's is headquartered there, but there are lots of other berries grown there: apples, grapes, artichokes, lettuces, and other vegetable row crops. Importantly for this application, almost 100% of their water supply is from groundwater. So we're really isolating this groundwater impact. And then the water agency collects pretty amazing data and charges a price, a volumetric price, for agricultural groundwater pumping. And what I'll explain in a second is there's a setting, what I would consider a quasi-experimental setting, where we sort of have a treatment and control group, although non-random, and I'll explain what I mean by that. But there's a setting that will help us to try to move away from correlation and try to move towards causation. So just taking a step back here to mention sort of why we care about agriculture and groundwater in California more broadly for this type of study, although maybe those who called in on this seminar are probably don't need this motivation necessarily. But agricultural sector as a whole is likely to be hit pretty hard by climate change and changing water supplies. As a sector, they're responsible for a large fraction of the global water withdrawals, lots of irrigated crops worldwide that are important for the food supply. And groundwater itself is an important component of the water supply. I had mentioned before that it's an important way to buffer other variability in rainfall or surface water. And then in California in particular, there was a groundwater regulation that passed in the end of 2014 that provides a statewide framework for groundwater management over the next several decades, or going into the future, to sort of regulate some of the historical groundwater overpumping throughout the state of California and associated negative impacts, such as declining water tables and land subsidence and deteriorating water quality. This legislation is called the Sustainable Groundwater Management Act, or SGMA for short. And what it did was classify the basins in the state of California and determined their priority level for management. These orange basins that are determined to be medium or high priority are all required to develop plans to manage their groundwater. And these basins account for the vast majority of the groundwater pumping in the state, something on the order of 97% of the pumping in the state. So it's a very comprehensive legislation in that sense. These basins have to develop plans for how they're going to achieve groundwater sustainability. And importantly, the local management agencies that are in charge of these plans have been given a lot of flexibility and an authority in how to achieve groundwater sustainability, including the ability to leverage groundwater pumping fees. And so this research sort of directly, has implications for SGMA and pumping fees that might be implemented throughout the state, either to raise funds to do supply augmentation projects or to do demand management itself. In either case, understanding how water prices are going to change the agricultural landscape is going to be important in the context of SGMA. So I'm now going to show you a little bit about the data that I'm working with in order to understand the impacts of prices on water and land use. Here's a map of all of the wells in our data set. Each black dot is a groundwater production well in the Pajaro Valley Irrigation District, where the service area is outlined in blue. So at each of these black points, we can observe the groundwater extraction quarterly. And we're looking between 2005 and through, I think, 2017 is our data, where we're seeing extraction at all of these wells. So the ideal experiment, if we wanted to look at how pricing affects water use, ideally we would want to randomly assign a subset of these wells to a higher water price, and then compare how their water use would differ from those who didn't receive the price treatment, right? But this is a real life context where we can't randomly give some subset of people a higher price than others. And so we have to work with what we've got. And in this case, we've got the next best thing, where all the wells that are in this purple region that are located near the coast, halfway through our sample period, received a higher price. So it's not random as to who received the higher price, but we do have a treatment and a control group, and we have a pre-treatment and a post-treatment period. And so we can exploit that, especially in combination with institutional knowledge about what created this separate zone and determined who got treatment, to try to understand the impacts of prices on water use and land use. So here's what the price treatment looked like in our setting. The wells that were in this purple region right here is called the delivered water zone, which I'll explain more later, but it's the acronym I'm using is DWZ. So prior to the third quarter of 2011, everybody was receiving everyone was facing the same price to pump water as a price per acre foot. And then in the third quarter of 2011, those inside the delivered water zone got a disproportionately higher rate increase that continued afterwards. So we're going to exploit this jump in prices that was only to those inside the delivered water zone to understand how the price increase affected water use and land use. So we're coupling this with annual land use data that the water district has conducted. They digitized this, created it through field surveys, and we have it for a subset of the years that we have pumping data for. But it tells us the crop composition and delineates what's irrigated versus non-irrigated agricultural land, what's fallowed, and also what is not agricultural land. So we could distinguish residential or just open green space from ag land. One thing you may have noticed is that the delivered water zone is right next to the ocean. And so there are certain properties about those farms that might be distinctly different from the farms that are in the rest of the valley. Thankfully, we also have data from a monitoring network of about 200 wells throughout the valley. Those are the wells shown here in purple that are measuring different groundwater quality metrics, of which the ones that measure salinity we think will be the most important in this context, and due to the proximity to the ocean and sort of the historical overdraft in this area. And we also have information on the depth of the water table, both of which will be important things to control for in our setting, since those who receive treatment were not random. One last challenge that I alluded to previously was that we don't really know how to match a well to what crops are being watered, which is important for sort of understanding what our observational unit is in this context. So what we do is grab the county tax assessor property boundary data and overlay those property boundaries onto the land use and aggregate water use within those parcels and treat those property boundaries as a farm unit in the analysis going forward. Okay, so I think I said this earlier, but our plan is to compare the water use and land use separately across these two pricing zones before and after the price change. It's this comparison between the treatment and the control group, where the treatment group is the group of pumpers that received a price increase in the third quarter of 2011. But because this is a non-experimental setting, it's really important to understand what determined the treatment. How did certain farms get assigned a higher price and others did not? What is the delivered water zone? What makes that zone special? What's driving this price change, et cetera. So I'm going to try to give a little background now on this assignment mechanism and what I understand about who received this, what I'm calling a price treatment, which will inform our statistical regression, because we want to control for these things. Because ultimately we want to argue that conditional on the differences, that assignment is random. Essentially, we need to make an assumption about the counterfactual world of those pumpers inside the delivered water zone. If they didn't receive the price increase, what would have happened to their pumping that we cannot observe? So what is this delivered water zone? From the name of it, it implies that those pumpers are receiving some delivered water. And what happened was that prior to our sample period, this zone was created. The water agency wanted to develop some recycled water supplies. And they initiated this pumping fee in order to raise revenues to fund this recycled water program. The recycled water program was created to try to help reduce some of the seawater intrusion problems that were happening because we have lots of groundwater pumping here in a coastal basin. And so, but they determined that if we, they couldn't make an unlimited amount of recycled water. The recycled water is in itself a very scarce resource. It's only maybe 3% of the basin's total water use. And they decided to allocate it only to some of the pumpers that were close to the ocean, because there were great benefits to the basin overall if those pumpers who were close to the coast substituted some away from their groundwater pumping and used the recycled water. And so we know that those who, I mean, this gives us reason for, well, for one, we know that those inside the treatment area, as I'm calling it, are receiving recycled water. And so that's a very important control variable in our regression. And it's something that we have data on and we can control for directly. But there's also reason to believe that those wells might differ in terms of their salinity, or the groundwater quality coming out of those wells will differ in their water quality, as well as potentially the depth to the water table that they're drawing from. The other thing we might be curious about is what drove the timing of treatment, and also, what drove the price split in the first place. And my understanding is that it had to do with a Prop 218 lawsuit. Essentially, someone outside the delivered water zone sued, saying it's not fair that we're all paying the same price, even though those inside the delivered water zone are the only ones receiving recycled water deliveries. And so as a result of that lawsuit, they decided to make differential prices where those inside the delivered water zone were going to pay more because they're receiving recycled water. But the actual timing of when this treatment came into play has to do with the timing of the settlement of this lawsuit, which went on for a bit. And so we can sort of potentially safely assume that the exact timing of when the treatment came in was random. Okay, so now let's start looking at some of this. Here I'm just showing the raw groundwater extraction data. This is average extraction by zone, quarterly well level extraction from the well level data. And the dotted line here correlates with the third quarter of 2011. That was when the price treatment came in. So you can't tell all that much from the raw data, of course. There are these large seasonal fluctuations that make it hard to see, but it does sort of seem like something different is happening after the price change when we're just looking at the raw data. So we're going to do this a little bit more formally and do a regression analysis to compare both water use and land use in separate equations. So our y on the left-hand side variable is either, it can be several different things, but it could, in our case, it's going to be water use, and then irrigated acreage, and then total agricultural land. So we're going to run 3 separate regressions where our parameter of interest, that's going to say sort of the differential effect to those inside the delivered water zone, is this delta parameter, which is the coefficient on this interaction term, where inside is a dummy variable that's equal to 1 if the user is inside the delivered water zone. And that dummy variable is interacted with post, which is another dummy variable for whether or not the observation was before or after the price change. So that's just a way of statistically comparing the treatment and control groups before and after the treatment. We're gonna, because this is a non-experimental setting, we wanna try to control for other things to try to get closer to causality in interpreting that delta parameter. So we're gonna start by controlling for parcel level fixed effects. That's the alpha I. So anything that is time invariant across all of these farms, such as the soil type that we might not think changes over this time period, but might be correlated with things, will be soaked up by this fixed effect alpha I. We're also going to control for what we call aggregate time varying shocks. This is the oh my gosh, what is that parameter? The one with the T subscript. These are going to capture these time varying shocks that anything that happens to everyone in the basin at any given point in time. So these are going to be quarter by year dummy variables. And then the next term are these control variables that we're going to include directly. And these are the ones I've mentioned before: the recycled water deliveries, groundwater quality, depth to the water table, and we have some other ones like, you know, the rental rates for the farmland, things that could potentially change at the region level over time that might be correlated with treatment and our outcome variables, and could, if we exclude them, could potentially bias our estimate of the treatment effect that we're after. Okay, with that mouthful of statistics, I'm gonna now preview some of our preliminary results here. First, starting with the impacts of prices on water use. We found that the price increase, which is about a 30% increase, led to a 28% reduction in groundwater extraction. This result was statistically significant and robust across several specifications, robust to the inclusion and exclusion of these different control variables that I mentioned, as well as some other tests. And we think this is a pretty large impact. I mean, I was sort of surprised with the magnitude of the effect that we're seeing here. So a fairly large, economically meaningful impact of water prices on water use. We're also seeing fairly large decreases in total agricultural land and irrigated acreage as a result of the price increase. We're seeing that the 30% increase in prices led to a 19% decrease in total agricultural land and a 14% decrease in irrigated acreage. And so you can see here that the impact on the total land in agriculture, so that's including fallowed land, is greater than the impact on irrigated acreage. And so the fraction of land that within agriculture, the fraction of land that is irrigated actually went up as a result of the price increase. That's what we're seeing in the data. And therefore, if you were to look at fallowed land just as a percentage of land in agriculture, it would be declining as a result of the price increase. And this is something that I thought was maybe a little counterintuitive when I first saw these results. But then in thinking about it more, I mean, I think it can be sort of justified by thinking that you know, in the face of a permanent price increase, if you were going to make some land adjustments, you might be more likely to sort of sell off or permanently convert your least productive agricultural land and maybe irrigate a greater portion of the land that remains in agriculture if the price is sort of perceived as a permanent shock. And so anyways, I think it's an interesting result. Again, these are all preliminary results, so still digesting everything as we go along. But we can also look at within agriculture, how has the price increase affected planting in different crop categories? So here's some of the regression table output that I spared you from on the previous results. But this is showing sort of by crop category, what are the, you know, this is the coefficient on that interaction term results. But what we're seeing so far is that agricultural water pricing is having significant impacts on both agricultural water and land use. We're seeing large reductions in water use. We're seeing decreases in irrigated acreage, decreases in the total amount of land in agriculture, and some crop switching as a result of the price increase. These results, especially once we're sort of pinned down the exact magnitude that we feel most comfortable with in this setting, it's going to be, I think, important in the context of the Sustainable Groundwater Management Act as agencies across the state are trying to figure out how to correct overdraft. This chart here is taken from a recent PPIC review of all of the groundwater sustainability plans in the San Joaquin Valley. And they found that of the overdraft that needs to be corrected, agencies on average are saying about 80% of that overdraft is going to be met with supply expansion projects, and the remaining 20% through demand management. So things like restrictions on pumping, other measures to reduce the demand directly, of which, you know, a corrective price or tax on pumping could be an example of an instrument for demand management. And they conclude that this is pretty optimistic to think that 80% could come from supply expansion. And so demand management is an important part of this picture in meeting sigma, in which case understanding the role of prices could be directly informing impacts in this demand management space. But even for the supply expansion, agencies are talking about implementing fees in order to raise revenue to fund these supply expansion projects. So even if the pumping fee is not put in place for the purpose of demand management, it still can have impacts on water conservation and land use change that I think will be important going forward in the implementation of SGMA. So that's all I have for you all today. Thank you for letting me present this work in progress, and I would love to hear any feedback that anybody has. Thank you.
Thank you so much, Ellen. That was fantastic. I want to open it up for questions. Does anybody who is still on and, you know, has have any questions? I have some, and I'm sure Sam has some, but I want to definitely encourage those who are joining us to take advantage of this opportunity.
Yeah, and if you want, you can either type it on the chat. Just let us know. Just speak up.
Hi, Alan. Great talk. Can you guys hear me?
Yes. Yes. Can you introduce yourself? Oh, here he is.
Yeah. Hi. This is Ian McLeod. I'm with California Department of Fish and Wildlife, working from home just like everyone else. And I just had a question. Have you considered that the total decline in agricultural land could be due to other factors apart from the water price? I don't know if that would impact your study. You know, maybe increasing urbanization. Maybe that would be different in the coastal area as well, where land prices are higher, perhaps.
Yeah, absolutely. That's a great suggestion. We, so far right now, in terms of residential pressure, right now we only have the farmland rental rates included in there, which is a regional variable. So to the extent that that varies and relates with, you know, the farm rental rates will be correlated with residential price, that land value as well. But that is something we have talked about, and something that I think we need to try as well, is getting some measure of that pressure on residential demand more directly to include that variable. I think it's a good point. Thank you.
Any other questions? Thank you for that.
Mehdi, do you want to ask your question?
Thanks, Ellen. This is Mehdi Nemati from UCR School of Public Policy. The great talk. I just had a quick question. Given that SGMA is developing right now, how do you see these other water districts or water or irrigation districts to use economic tools like pricing to achieve reductions in groundwater use?
How do I see them using it?
I mean, do you see if they are going to apply it? Do you know, have just an idea of how many of them are going to, how popular is economic tools like pricing or tax or other things that they are going to use besides these other tools? Yeah. Thank
Yeah,
you.
that's a good question. My general understanding is that pricing as an instrument itself is not a very popular one, although several of the agencies that I've read parts of the plans of are talking about leveraging fees in order to raise revenue. So it's sort of for a different purpose, but might still be meaningful in that context as well. But I do think economic instruments in general have received some attention in the context of SGMA, in that several groundwater management plans talk about the potential for groundwater trading and markets for groundwater. And so, you know, it's sort of a broader answer to your question that I think there are interests in economic instruments, less so on price directly or taxes directly as a corrective instrument.
Thank you.
I think Safiq has a question.
Hi, Alan. This is Safiq Khan, Cooperative Extension Specialist in Water and Watershed Sciences. So earlier in your talk, you alluded that increased pricing might bring more innovation that might help, save water.
Mm-hmm.
And I'm just curious if you noticed any of that where the farmers are trying to be more innovative to maximize their water use instead of letting the land to go fallow.
Yeah, that's also a great question. It's something that I've been very interested in, but I find it challenging to get information on that sort of at the farm level, how these farmers are making adjustments in terms of irrigation efficiency. It's something that I've looked for in this area, and we've gotten some county-wide statistics on irrigation efficiency, and so we might be able to make some comments on sort of trends at the county level, but we won't be able to sort of pin down the same sort of empirical estimates that we're doing on these other factors, because we just don't have the same data on irrigation efficiency at the farm level.
Kind of as a follow-up to that question, Alan, what would be your dream data? Like if you had the data to assess irrigation efficiency, like what would you want that to look like?
Yeah, I mean, ideally, knowing what sort of irrigation technology is being used at each of these farms. Each individual farm, because that's what we're working with here. And the reason we kind of like having the most micro level data as possible is because then we can throw in a bunch of control variables that can soak up things about the individual farms that are unobservable to us. Like we think of something like there might just be differences in the way farmers farm that explain differences in outcomes that we can't possibly observe. And so it's helpful to have this like most granular level possible.
I was thinking about it, and I was just, as a part of a different project, I was looking back through sweep applications, and I wonder if that could be used somehow. If you were to look at the number of sweep applications that came out of the area that had the higher cost versus the area that didn't, and the types of technologies that they were trying to apply to get funds to do, that might be something. And I don't know how spatially explicit those applications are, but it could be like a good proxy to get at that question, because that, as an irrigation person, that's very interesting to me.
No, I'll look into that. Thank you. That's a great suggestion.
Any other questions? Let me see if any other hands have been raised. Maybe, I think that you're, oh, he took it off. Okay.
I do.
Yeah, go
I
ahead,
do have,
Sam.
So, Ellen, I think something that more than a question, perhaps an open discussion in terms of the last, I'm not sure if it was the last slide or the previous to the last slide of the PPIC. and still kind of thinking of this, where can I get the water, rather than actually thinking like, okay, in all honesty, I've been spending more money that I have. My credit cards are over the top, and I mean, I'm thinking a way of, and one of those might be to, I mean, if you increase the interest rate, I mean, people will get a hand like, okay, I cannot keep spending as much. And I think in this one is when you're reading all these different GSPs and so on, how vivid is or how often do you see, yeah, I'll have to do some water demand management. I think are you seeing serious conversations about that?
I mean, I haven't done my own like very comprehensive search of the groundwater plans. I've looked in some specific areas where I've dug into the plans and have not been overwhelmed by the details on the management actions. And in what I've seen a lot of times saying, you know, we'll consider X, Y, and Z and be very comprehensive. And that might include demand management, but it's not giving any specifics as to what, and definitely seen an emphasis on the sort of supply augmentation side of things. But yeah, I mean, even just looking at this PPIC graph, I mean, this is their review of all the GSPs in the San Joaquin Valley. And I'm pretty sure their takeaway is that there isn't enough water to do all of this supply augmentation, right? Yeah.
Yeah, and I mean, in Pajaro, they have these, I think it's water conservation groups, water conservation talks between stakeholders. I mean, one of the good things about this area is that they've been trying to do this water savings. Yeah, the problem here is that if either you do it or you start extracting saline water, which is not the case of other places where you don't have any water, you just dig a deeper well. And I think that's what have made these guys kind of come with their back against the wall. But anyway, I think we were having these more serious conversations of water conservation. Any other question, comment?
I have a question. And I guess I was wondering, as someone who's relatively new to California, how much of the data for this study was specific to Pajaro Valley, where it was data that community had collected? Because I know that in several cases you were like, well, you know, the community had collected this, the district had collected that, and how much data, like, and I'm just thinking of like transferability to other studies in the region, you know, and this issue of districts internally collecting data versus, you know, statewide data availability.
Yeah, I mean, I had to sign a non-disclosure agreement with them to work with this data. I mean, this was like what the agency collected, and it's privately held, and so at least that's the case for like the groundwater extraction at the well level. And I think if you're, you know, wanted some more aggregate measures, that stuff's publicly available. As well as the land use, which doesn't have the same sort of, I don't know, confidentiality around it. But yeah, in general, I think that that's something that's lacking at sort of the state level. There isn't sort of any groundwater extraction data that's collected at the state level. There are other things like the CASGEM, you know, well level data. I couldn't even tell it, groundwater monitoring, California Groundwater Monitoring Network or something like that. And so there are other things, and especially in the context of SGMA, DWR has made a portal where they've made a lot of data available statewide, and it's a great way to go, place to go now for some of these variables. But yeah, I mean, that's part of the reason we were excited about this specific setting, is because we had this collaboration with the irrigation district that Sam actually helped me with an introduction, like years ago, this has been an ongoing thing for a while. And that's part of why I was so excited about it, is because of their sort of unique data and setting.
I do also think, Malika, that what you're seeing in Pajaro Valley is kind of some of the data that we may have available in the future for other places or for other groundwater basins.
Yeah, I'm just thinking about that tax parcel level groundwater extraction data and how useful it is to study irrigation climate feedbacks. Because I used a similar data set in the Midwest to look at and think about irrigation as like a time varying climate forcing, and looking at how the irrigation induced changes to climate change on a yearly basis, as opposed to a lot of the climate studies that just say, okay, this is irrigated lands. Let's assume that there's going to be a certain amount of cooling that's associated just because it is irrigated, as opposed to how much water vapor is going to go into the air as a result of ET. So just kind of thinking with my climate change hat on, those data are really valuable. All right, we've got 4 minutes, and we're always very respectful of time, and we like to end at 5. So if you have a burning question, now is the time to ask it.
So when do you think, Ellen, is this a report, or when are you, what is your timeline of this project, this report for submitted, being available?
Yeah, I'll have a working paper available very soon. I don't know how familiar you all are with, in general, in economics, it's very common to share working papers because there are huge publication lags. And so anyways, it'll be years before it's an actual publication, but months before, when I can have something that I can share and feel really good about sharing with you all. And I'd be happy to do that once I have something.
That's wonderful. I have an extension question, as long as, no one else wants to ask a question. I will ask one more question about, like, how is it extending this information about these benefits that have come from the cost back to the community and the district? Do you think that the study results are going to be received positively? Like, are there things that you're concerned about? Like, how do you feel, I guess, about the extension component here? Because it really is a valuable piece of extension work too.
Yeah, I mean, it's interesting where I think that the extension value in this work is towards other groundwater basins that might be interested in a fee under SGMA, and less so for this specific irrigation district that already has this fee. They're doing recycled water. They've got all of this. They have tons of conservation programs already going on. And are really at the forefront of basin management already. And so, yeah, I mean, it's something that I need to work on in terms of finding the right people to connect with in order to, talk to the right stakeholders where this could be valuable, because I really do think the value is in the context of SGMA for basins that don't have a fee and want to know what the impacts of a fee might potentially be. And so that's part of why I'm very grateful for an opportunity like this to start, start talking about this work and let it potentially lead to other connections and find the right stakeholders.
And, Ellen, I think that's, it's very good as you're putting this, because many of the people that are in the GSAs, many of the members of the groundwater sustainable agencies, they may come also from the surface water world, and they can actually see how, doing this a price management to kind of switch from either surface water to groundwater, or what will be the impact on doing these prices, may increase or may provide some savings in there. So I think that also in that context, and putting it, not, as you're saying, not only for that area, but for the rest of the state.
Yeah.
Yep.
Yeah.
Well, I think that's a fantastic note to end on. So thank you so much for doing this, Ellen. And to those of you, this is fantastic. And please join us again next month. Our speaker will be Josue Medellin, and he will